Hello friends and welcome to AS Education. In the last video we have seen one simple problem from isometric projection. In this video we are going to cover one complex problem from the isometric projection where two views would be given to us and accordingly we are supposed to draw its pictorial object, that is what isometric projection of that figure. But while doing this we are going to learn what do you mean by isometric axis and why we use this isometric axis concept, because many times the edges of the objects will be their true length and many times it will not be the true length. We'll see detailed conditions when we called it as a true length. I will try to draw one isometric projection problem. The two views of the object is given, that is front view and top view, and by looking at these two views we are supposed to draw the 3D object or pictorial view of the object itself, which will be a 3D figure. Now here we have been given this origin point like in earlier figure I just shown you. So friends, like orthographic projections, isometric is also quite similar to orthographic projection itself. The way we find out the overall length, breadth and height in orthographic projections, and then after calculating all these overall dimensions we just get the frames for front view. Front view would be length versus height, top view would be length versus breadth. Like that, in the similar way we are going to calculate here the overall dimensions, and then we will be creating the similar kind of frames in isometric diagram also. So very first of all we will try to calculate all these overall dimensions. If we see the length of the total object, the 80 mm length is given from origin point towards the center of this prism itself. After this center line, how much distance it is going on right hand side or till this vertical line, it is not given, but if we draw the circle of this much radius, that is 30 mm distance, because the size of hexagon is given 30 mm, we can see the radius of the circle would be 30 mm. Of course this distance would be less than 30, but right now we will consider the total length as 80 plus 30, that is 110. So we are getting length is equal to 110. The total breadth we are getting, that is 50 mm. In the top view you can see the total breadth of the object. And the total height you can see 40 plus 20, that is 60 mm is the total height of the object. So if we observe, the scale of this text is very much less, so we'll just select this text and then we'll change the scale here from 0.2 to 6 or 7, and then I'll press enter, then just close it. Friends, here the total breadth would not be 50 mm because we can see apart from this plate or apart from this block there is some part of this prism which is moving beyond these lines as well. So we want to find out the distance from this point to this point. That would become exactly, if this is a 30 mm, this distance also would be 30 mm. So this 30 plus this 30 total would be 60, not the 50. So we'll make corrections here. Breadth, instead of 50 it is 60. Now we know the origin point, and towards the right hand side of origin we can see the front view itself. So once you click anywhere as origin point, I will take projection layer to draw the frames. Go to the setting, snap mode setting. In the heading of snap and grid you can choose isometric snap in snap type and then click OK. So you can see the grid is changed. Just make sure that ortho mode is always on. Then take line command. So to change the orientation of this line, either you press F5, otherwise there is one option is given over here, that is iso draft. Just click it over here and here you can change the orientation of that plane. I want iso plane right, so I will click this iso plane right. So from the origin towards the right, the length is being made, that is 110. So I just created the total length. Then I'll draw the total height, that is 60, 60, enter. Then towards the left again it 110, and then it will come downward by 60. Now towards the left from origin point, come to the iso draft, click on isoplane left and create a line towards the left by 60 again, because the breadth is 60, height is again 60, and then it will come to the origin point here. Similarly, you can draw the top plane. In the top plane, length and breadth can be seen, not the height here. So from this point, I'll select the isoplane top. I want to draw a line 110, that is the length, and the breadth as 60. So these are the three frames we have just created, one for front view, one for side view, and one for top view. Now before you are going to draw the object from origin point, just check how these lines are started from the origin point itself. Now in our question, you can see the origin point is given at this front view corner point. So whenever you want to draw any line, you have to look at that line in front view as well as in top view. So when I try to draw this slanted line which starts from origin, and when I look at its projection in top view, you can see this is the projection of this slanted line. This is what this line indicates, the slanted surface here, which starts from origin, because exactly above the origin there is no any vertical line present at that in front view itself. So from origin point, this slanted line represents the slanted surface from this origin point itself, and then after this edge, the surface is becoming what? A horizontal one, which can be seen in the front view itself. But when you try to draw this line, or we don't know exact length of this line which is coming to this hexagonal prism itself. So we'll try to draw this hexagon first, which will be at a distance of 80 mm, or whose center will be at a distance of 80 mm from the origin point. So I'll change the layer to the center layer one, and then I'll draw the midpoint to midpoint as the center line. Now here the center line cannot be seen as a center, so to change the scale, command is LTS. By default it is showing 1.3, no change. So by reducing the scale, the line is not being visible. Now I'll increase the scale. Instead of 0.3, I'll make it 6, enter. So here you can see now the center line is visible. Now we know that this is the distance 80 mm. This center line, vertical center line, at a distance of 80 mm from this origin point itself. So we'll measure 80 mm from this line, 80, and then I'll go to the end point itself. The unwanted lines you can trim here. So this line is present at a distance of 80 mm from this line itself. Now these two center lines we have drawn on the top profile, and on the top profile we can clearly see this hexagon and this circle. But this hexagon, or regular hexagon, can be seen only in orthographic view when you are looking at perpendicular directions. Once it is tilted, it cannot be drawn as regular hexagon. So to draw how it is tilted, or to draw its projection in isometric view, you must draw this regular hexagon in extra space, and then by taking measurement from that regular hexagon, you can draw its projection in our isometric view. Now to draw the regular hexagon, please go to the snap setting again and click on the rectangular snap, and then click OK. Click on the polygon. It will ask you the number of sides. Give here 6, enter. Center of the polygon, inscribe in a circle, and then I'll give the radius of circle as 30, because side of the hexagon is given 30, and then enter. I will rotate this hexagon because I want this hexagon in such a way that it's one of the side on right hand side itself. So to have one of its side on right hand side, I'll rotate this diagram by 90 degrees itself. So now you can see here we are not going to get the regular hexagon, but we know the distances we can take measurement from this regular hexagon itself. So while taking these measurements from regular hexagon and placing these measurements on this top plane, on isometric top plane, we have to understand which line will be the true length and which line will be the apparent length, for which we have to understand the isometric axis concepts. So here isometric axis is nothing but the line which is originating from origin point. That may be the horizontal line in front view, horizontal line in side view, or any vertical line that is present in that diagram. So these isometric axes help us in identifying the true length of the line. The lines which will be parallel to any of these isometric axes will be the true length. And if it is not parallel to any of these axes, that will not be the true length. So friends, once you place this hexagon on this top plane of isometric plane, you can see the two sides of the hexagon are parallel to one of the isometric axes, and at the same time the axis lines are also parallel to the isometric axis line. So in this case, the two sides of the hexagon and the two axis line will be the true length. The rest of other lines will not be the true length as they are not parallel to any of the isometric axes. So while placing this hexagon on this top plane, we will mark the true length on the axis line first, and then we will draw the other two lines of the hexagon, which are also the true lengths. So we'll try to get the projection of regular hexagon in terms of dimensions. So guys, you can see here this vertical side from center of its hexagon at a distance of 26 mm. This distance is of course 30 mm itself because it is a radius of that circle itself. Still we'll measure that distance. So this is what 30 mm we are getting, and this distance is 26 mm. So we'll try to get projection of this regular hexagon on this isometric plane here itself. So very first of all, at a distance of 26 on right and left hand side, we'll copy this center line itself. So go to the snap setting again, select the isometric snap, click OK, go to the copy command, select the line, right click, click any one point on the line, drag the mouse on right hand side, give distance 26, enter, on left hand side 26, enter. So these are the two lines we have just created here. We want to project one more line over here at a distance of 30 mm up and down, and we have this total as 60 mm distance, so this distance would be 30 itself. So now we can just change the layer here to the continuous one, and then by taking a line command we can draw the line here. From this point I'll draw 15 mm vertically up, 15, and then from this point to the end point we have just drawn a line here. Similarly, from this point again towards the downward side, we will measure 15 mm, that is half of the 30 mm distance, and then from this end point we will draw, will join this end point itself. Now I'll just erase this line. Now similar way, you can draw a line from this point itself, vertically up by 15, and then connect that point with the end point itself. From this point again we will measure 15 mm downward, and from this end point to end corner point over here. So this way we have just created, you can see we have just created this projection of this regular hexagon itself. This gap is there because initially we have considered this distance as 30 mm, but it was less than 30 mm, so that's why there is one gap here. So we'll take line command here. From this point, ortho mode should be on. Please change the orientation. Now it's time to draw the prism length, which is having height as 20 plus 40, that is 60. So 60 mm is the height of this total prism. So these vertical edges we are just going to draw from this corner point itself. Take a line command. From this corner point, I'm just going downward, and then drag the mouse in downward direction and give distance as 60, enter. Now you can see here, this is the prism length we have just created. Now this profile also can be seen over here. So I'm just copying this profile of this hexagon from this line. Right click and left click on this point, and the second point you should click on this end point itself, so that all this profile has been copied from this point to this point. Now the remaining vertical edges you can draw with the straight line itself. Go to the line command, just join all this corner point itself. Once you draw this prism, now it's time to draw the circular hole. As you can see in the diagram, the circular hole, which is having diameter 40 mm and it is having depth as 20 mm itself. So to draw the circle, you know that as this object has been tilted, so this circle cannot be seen as a circle itself. So instead of circle, it can be seen as ellipse. So for that, the command is ellipse itself. Type ellipse, enter. Before you are going to click any point, just see in the bracket arc, center and isocircle. You have to click isocircle first. Then it will ask you specify center of the isocircle. Now you can click the center point of the isocircle, which is the intersection of the center lines. Now the way you are going to drag the mouse outward, you can see the circle is being made, but it is in wrong plane it is being made. Now to change the orientation, either you can press F5 or you can change the setting from isodraft itself. I just click isoplane top, and I want radius as 20 because the diameter was given 40. So I'll give 20 and enter. So this is the way the circular hole can be seen. You can just turn off the center line if you want. So friends, this circular hole is not a through hole. It is having some deep or depth as 20 mm. You can see this circular hole is having depth of 20 mm. So we have just drawn a circle at the top plane itself, but at the bottom edge also the part of circle can be seen here itself. So whether it is visible or not, for that we have to just copy the circular profile by distance of 20 mm in downward direction. So take a copy command, select the circle, right click, click anywhere on the circle, try to drag the mouse in downward or change the orientation, then try to drag it in downward, give distance 20, then press enter, then press escape. Now inside this circular hole, the part of the circular edge at a distance of 20 mm you can see here. So only that much edge to be kept over there. The remaining part should be trimmed. So friends, this is what the prism we have just drawn. Now we'll try to draw the remaining part, or we'll try to draw the line which starts from origin point. So here you can see from the origin point, this line is not being started because we have just created line or breadth of width 60 mm instead of 50. So the origin point will be somewhere here. So to project exact this 50 mm line, which will be identical from the center line, so we'll draw the center line first. take a midpoint of the line. Now just take a reference of the center line to draw the 50 mm line, which will be identical around the center line itself. So change the layer to the continuous one and take a line command. I'm just going to draw a line on left hand side by 25 mm. Similarly, I'll draw a line on right hand side by 25 mm. So that this is what the 50 mm length has been just created. This 50 mm length, which can be seen in the top view itself, which is present at the line which starts from origin O. Now we'll try to cover this slanted surface, but the slanted surface is given at an angle of 45 degree. As we have seen, the angle which can be seen in orthographic view cannot be predicted in isometric projection, because the angle or the object might have been tilted completely, so it would be very difficult to predict that angle in isometric projections. So in that case, to draw this line, we must have one point. As we have one point over here, we must get another point so that we can join these both the points by straight line. So once you get one point, to get this another point, we should go in backward direction. So from this origin point, from this point toward the right hand side, we'll try to draw the line itself. Now it would be very difficult to catch exact point there itself, so I'll extend that line beyond it and then I'll trim it. Now you can see I have drawn a line which indicates the line is coming exactly on what? The prism surface itself. Then after coming to this prism, it is moving to the height of 30 mm itself. So we'll draw 30 mm height from this point itself. 30, enter. Once you draw this vertical line, we must know that how much distance this line covers from this end point to this end point. But this length is also not given over here. Now to get this length, to get the measurement of this line, we must draw this much profile in extra space, in that would be in orthographic projection itself, so that we can take measurement from that point itself and we can draw this line here itself. So I will go to the snap setting, rectangular snap, click OK. Now I'll try to draw this profile as it is there itself, so that we can take the measurement of this line. So we don't have this length as well, but this length we can measure from isometric projection we have just drawn. Now to measure this dimension of this aligned line, you can click over here and click on the aligned and click on these end points of the aligned line, and you can see the measurement of this line as 71. So we will draw 71 mm horizontal line. Then it will go up 30 mm, 30 mm. From this origin point, it is 45 degree. Tab key 45, enter, and then we'll draw a straight line from this right hand side line, and then we can trim both the lines, unwanted lines. Then we can measure the dimension of this line itself, which is 41. Now we can draw this 41 mm line from this point. I'll just delete this dimension because we never give any dimension in isometric projections. Take line command again from this end point towards the left. Now we are in a rectangular snap, so we must go to the snap setting, click on isometric snap, and then click OK. Take line command from this end point, try to draw a line of 41 mm which we have just measured, and from this end point we are supposed to join these two end points by a straight line. The inside lines will get trimmed. So we'll try to draw this top surface first. I want to copy this line beyond this surface itself, so I'll just copy this hexagon line, right click, and just try to match this or try to align this point exactly on this point. Once you get that base point, just click over here and just drag it downward and just paste here. The remaining line you can just trim it. Similarly, now you can copy these another lines of hexagon from this point to this point. So this line also cannot be seen now because this would become what, a plane surface here itself. Now we'll try to copy this line on from this point to this point, end point. The remaining lines would be trimmed. This line also cannot be seen because this would be a plane surface. This is a top surface, and as this is a top surface, there can be seen one edge because the surface has been bent. So we'll show one horizontal edge present at this corner point. So this way, this horizontal surface, top surface, has been bent at this edge. Now apart from that, in this block, one dotted line can be seen, which is a slot here, rectangular slot. Now this rectangular slot has been started 12 mm from the base, which is 20 mm towards the right from this point itself. So we'll measure this 12 mm on this because 12 mm is given vertical dimensions. So we will measure this 12 mm on vertical line itself first. We'll take projection layer. From this point, we will measure 12 mm vertically up, and then we'll press enter. Now, this is what 12 mm height we have just taken here, which will be intersecting on this slanted line at this point itself, given point. So friends, once you get this point on the slanted surface, just project that point on left hand side as well. Now this line we have just drawn, but on that line we have to mark 30 mm distance, which will be identical around the axis line itself. Now this is what we have just reached 30 mm line, is 30 mm line. Now it will be moving till 20 mm horizontal distance from this corner point itself. If this is 30, this is 50. 50 minus 30, it is 20. So 10 mm on this side, 10 mm on this side. So I'll take line command with the help of projection layer, and from this corner point I'll measure 10 mm, enter, and towards the right it should go 20 mm as it is given 20 mm, and then towards the left it will come to 30 mm. Again towards left it will come to the 20 mm. So now we can change the layer to the continuous one. Take line command, just join this end point, complete this profile. So you can see here, this is a rectangular slot. Now this can be trimmed. This line which is coming inside this slot, that can be trimmed. But when it is a rectangular slot, there would be certain edges can be seen over here. So we'll try to draw these edges. From this corner point, we'll drawing edge going towards the right, but make sure that no point is being catched. Similarly, another line will be coming from this corner point. So I'll draw another line here. That should be vertical line. So change the orientation again. You can change or you can turn off the center lines also, and projection layers also. So friends, this is what isometric drawing. One more line is left here because this is vertical surface, we can see this is horizontal, and again this is vertical here. So between this vertical surface and horizontal surface, there one more edge can be seen from this point onwards. We'll try to trim that line as well. This way we can present isometric projection using AutoCAD drawing. So friends, this is isometric projection and I hope you understood how it can be drawn. I will try to cover more number of problems on these isometric projections. So till then, keep practicing the complex problems which comes under these isometric projections. So guys, thank you for watching.